Hey guys, Mr. Mailhot here for Bridge to College Mathematics. We're in lesson 6. We've been talking about properties and things that make expressions equivalent. We're going to focus on the distributive property, everybody's favorite. It is probably the most used mathematical algebraic tool through all of algebra. Comes in all the time. Let's get going. So task 19 says, are these expressions equivalent? Sketch and simplify to prove. If the two expressions are not equal, write a correct equivalence. Correct equivalence. Ooh, tongue twister. All right. What one do you guys want to do? Let's try number 1. So when it says, are they equivalent? They're kind of asking this. This is how I picture it in my mind. They're saying, is this equal to this? Are they the same? Would they get the same value if we plugged in any number in for x? Or can we do something to this to make it look exactly like this, or vice versa? Let's try it out. We'll go with the area model here second. Distributive property usually looks like this. We multiply the terms out front to whatever's inside. If there's more than one, we distribute all of them through. 3 times x gives you 3x. 3 times 3 gives you 9. Now, is that the same as 3x plus 6? No. One has a 9, one has a 6. Can you see where someone might end up with this? Where they might think they are equivalent? Where they could get something like this? A common mistake, right? People will go, oh, okay, 3 times 3, yeah, 3 and 3 is 6. No, that's 3 plus 3. 3 times 3 is 9. So, are these expressions equivalent? No. And don't leave that equal sign hanging out there. They are not equivalent. We'll fix it in a second. Let's look at it here as well. Area model would tell you like this. 3 times x plus 3. 3 times x, 3x. 3 times 3 is 9. The whole area of this is 3x plus 9. All right. We showed it both ways. I mean, it works here and here. But again, it's not equivalent to 3x plus 6. Write a correct equivalence. So what would I need to change here to make it work? Well, how would we end up with a 6 instead of a 9? Well, if this was a 2 instead, right? Because 3 times x would still give us that 3x, but 3 times 2, yeah, 3 times 2 is 6. We'd get it. Cool. So if you changed it to a 2, that would work. Let's try another one. Let's go on the next page. Well, number 5 looks like maybe a little bit harder. There's more stuff going on. Let's try number 5. So, are these... I don't know where to... There's not enough room. Are these equal? Let's see. X times x. Yeah, x squared. We're good. X times y. xy. We're good. Oh, plus xy. Because there's a plus sign right there. X times 2 gives you that plus 2x. Let's see, are they the same? X squared, xy, 2x, all pluses in between. Yeah, we're good. Yes, they are equivalent. Area model, let's try it. So we're saying if this length was x, and this length was x plus y, man, it is early in the morning, guys. I'm sorry. It's x plus y plus 2. Remember, we get the side lengths of it for these area models from the two things we're multiplying. So one side length is x. One side length are these 3 things, which is why we split it up into 3 boxes. If there was 4 things, we'd have 4 boxes. The last example, there were 2 things, we put 2 boxes. X times x gives you x squared. X times y gives you xy, x times 2 gives you 2x, and there it is, x squared, xy, 2x. We're good. I know a lot of you are confident with distributive property, so that's good. We're ready to keep moving on. Come to class with questions and be ready to work. Remember, we're mathematicians. We can do anything we want. See ya.